Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 6.1, Problem 4. This is Section 6.1, Problem number 4. It says, consider the probability distribution shown below. And then there's a bunch of questions about it. The first question, is it a valid probability distribution? Well, just intuitively, of course it is, because if it wasn't, then you wouldn't be able to answer parts B, C, D, and E. So the answer is going to be yes, but let's talk about why the answer is yes. First, everything in the first column is a number. That's one of 3 rules. Second, everything in the second column is a value that's between 0 and 1. That's also satisfied. That's the second of 3 rules. And the last rule is that the total of the second column is 1. So to add the decimals quickly, I just think of it as money. 45 cents and 10 cents is 55 cents. 55 cents and 45 cents is $1. So it does add up to 1. You could do it on your calculator, but as soon as I see it as money, I can do it easily without the calculator. So part A, is it a valid probability distribution? Yes, it is. Again, because it satisfies the 3 rules. Everything in the first column is a number. Second column, everything's between 0 and 1. Total of the second column is 1. Part B, draw the histogram. So again, for histogram, they're looking for the bar graph. Histogram is kind of a special type of bar graph. The bars have to be vertical as opposed to horizontal, and they have to touch. So I'll see if I can squeeze it in right underneath. My biggest probability is 0.45, so I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. 0.05, 0.10, 0.15, 0.20, 0.25, 0.30, 0.35, 0.40. 0.45 is big enough. So the first bar goes up to a height of 0.45. Let me fix this one, 0.45. And the value from the first column that goes right under the bar is 1. The second bar goes up to a height of 0.10. It's 0.10 on my number scale. Try and make the bars the same width. The number from the first column goes under that second bar. And the third bar is also 0.45. So I'm going to have to just slice off the bottom of my probability distribution a little bit. There's my height of 0.45. Again, the bars touch and they're vertical. And the number from the first column goes right under the center of the bar. So there's the histogram, or bar graph, for this probability distribution. So that's the answer for B. C, find the mean. So again, this is the average value if you conducted the experiment millions of times. So to find that mean, what we want to do is multiply every value from the first column times its probability, get those answers, and total them up. So in the first row, the number from the first column, 1, times its probability, 0.45, gives me a result of 0.45. The second row, the number from the first column is 2, times its probability, 0.10. 2 times 0.10 will be 0.20. And then the third row, the number from the first column is 3, times the number in the second column is 0.45. So 3 times 0.45 is 1.35. And now if you add these up, again, think of it as money. Adding them without the calculator is tough until it's money. Once it's money, it's very easy. 45 cents and 20 cents is 65 cents. 65 cents plus $1.35 is $2. The total is 2. Or you could do it on your calculator. You'll still get 2. So that's the mean, or some books would call it the expected value of the probability distribution. So D, find the variance. So for the variance, this is a measure of how spread out the results of your experiment are from one trial to the other. What you have to do is fill out a chart and get a total of the last column. So the chart, put it underneath, we're going to have a few columns. The first column is x. The second column is x minus mu, the mean. The next column is x minus mu in parentheses raised to the second power. And the last column is x minus mu in parentheses to the second power times the probability of x. So the first column for x is simply the values of x that are given in the question, 1, 2, 3. So x is 1, 2, 3. That column's the easiest. Now the next column, you're going to do x minus the mean. So in the top row, x is 1. So 1 minus the mean is 1 minus 2, which is negative 1. In the middle row, x minus the mean, x is 2. So it'll be 2 minus, the mean is also 2. 2 minus 2 is 0. And in the third row, x minus the mean, x is now 3. So it'll be 3 minus, the mean is 2 in each one of these rows. 3 minus 2 is positive 1. So now in the next column, we're going to take the result of the x minus mu that we did in the previous column and raise it to the second power. Top row, x minus mu is negative 1, so we'll do negative 1 second power. Negative 1 times negative 1 is positive 1. The negatives cancel. Again, negative times negative is positive. The middle row, my answer for x minus mu was 0, so we're going to raise 0 to the second power now. 0 times 0 is easy enough. That's 0. And in the bottom row, the answer for x minus mu was 1. So 1 will get raised to the second power. 1 times 1 is easy enough also, is 1. So one more column left to go. We're going to take the x minus mu second power answer that we had and multiply it times p parentheses x, which stands for probability of x, which is given in the problem. So in the top row, the x minus mu second power was 1 from the previous column, times the probability of x in that top row, which from our question is 0.45. 1 times 0.45 is 0.45. Now in the middle row, the x minus mu second power answer we got was 0. So it'll be 0 times probability of x. So again, middle row, probability of x is 0.10. 0 times 0.10 is 0, right? 0 times any number is 0. And finally, in the bottom row, the x minus mu second power answer that we got was 1. And that'll be multiplied times probability of x from the bottom row, which is 0.45. 1 times 0.45 is 0.45. And now to finish our variance, what we want to do is get a total of that last column. And again, they're decimals, think of them as money. Think of 45 cents plus 0 cents plus another 45 cents is 90 cents. So that's the answer for the variance. What's the variance? It is 0.90. You don't really need the 0 if you want. You could just call it 0.9. It's the same as 0.90. And finally, E, the standard deviation. So the standard deviation is the square root of whatever the variance was. So square root of 0.9. And that's 0.9 something. It's like 0.94. You can get more decimals than that with your calculator if you like. But it's basically the square root of 0.9.